All right, we're on the t-test to sample independent groups tab. And what's different about these series of tests is we're actually adding another test on top of it, and that is testing for equal variance. Okay, so basically we're saying where mu1 and mu2 are the variances, is there a difference in the variance? No, they're the same, or the alternative that they are different. If we fail to reject the null, the variances are the same. We use a pooled variance. If we reject the null, the variance is not the same. We use unequal variance. And that's not going to make a whole lot of sense until we start getting into one of the problems. So we have two sample independent groups, group 1, group 2. Two groups produce toys. The data is from a 2-week sample. Are the groups different? Okay. So my null, group 1 is equal to group 2. My alternative is not equal G2. Critical value 95%. 0.5. Decision rules. Okay, and let's get our results. All right, so my hypothesis test compared to independent groups. I'm going to clear everything out here. We have data input, so group number 1. Don't forget to highlight the label. Group number 2. Okay, I'm going to start off with the pooled variance, hypothesized difference 0, my alternative not equal, 95%. But then we're going to be testing for equality of variances. This is very important because that's what's going to be giving us the results we need for this section. And we push OK. All right, so we're looking at the results, and the first thing we want to look for is this guy. And just as a refresher, let's highlight this information. Okay. If we fail to reject the null, the variance is the same. If we reject the null, the variance is not the same. So we would have pooled variance. Okay. So let me just do that. Show that one as well. Okay. So in this case, we failed to reject because the p-value is definitely bigger than 0.05. We failed to reject, therefore we are using the right one, the pooled variance. Then, okay, so we make sure that we are using the pooled variance. Then we can say, okay, what is our p-value in this case? 0.5189. So I'm going to say 0.52. Is greater than 0.05. Therefore, we fail to reject the null. Meaning, there is no difference between the two groups in terms of production or however you want it. So basically, group 1 produces the same as group 2. All right, moving on to the second example. This one's going to be obviously an unequal variance, but let's go through the steps. Two different groups, 2-week sample. Does group 1 produce more than group 2? So my null, in this case, group 1 is less than or equal to group 2. My alternative, group 1 is greater than group 2. Critical values, 95%, 0.05. Decision rules, similar here. Okay, and let's get our results. So we'll go to my add-ins, megastat, two independent groups. So my group 1 is going to be over here this time. My group 2. I'm going to keep it at pooled variance for the time being. And my alternative in this case is greater than. And we're pushing OK. All right, I'm going to bypass all of this information. Remember, if we fail to reject, it's pooled variance. If we reject the null, it's unequal variance. It's pretty low p-value, or 99.9% confidence. So I'm going to say the variances are different. So therefore, we need to use the unequal variance, which means we use the wrong test. Which means we need to run it again. Simple enough, though. We go to our megastat, hypothesis test, independent groups, and leave everything exactly the same. One little click, t-test unequal variance, and we push OK. Same result, looks good. Now we're using the correct one. Unequal variance. Here's our means, standard deviations. Yeah, they're pretty different. And then our p-value is 0.09. Okay. So going back to our result. Is greater than 0.05. Therefore, we fail to reject the null. Okay. Now let's remind ourselves what the null was. It means that they are the less than or equal to each other. So analyze the results. Group 1 is the same or less than group 2 in production. Now, looking at the output, you would say, well, G1 seems to be doing a lot better, at least, by 10. Well, the problem is this standard deviation. They have a lot more volatility, so they could be higher or lower or the same. We don't know. What we do know is, well, it may look like G1's bigger, is not necessarily true. Okay? So we have to be careful about that type of thing. Okay, so that is the t-test, 2 samples for independent groups.